DevOps really came from the rise of, there's two trends here. I think it's helpful to talk about both. The first is it's fundamentally a shift in how people are building software. So in the old days, you have what we call a monolith, which is one giant application, right? So all the things that it does, let's say you have an e-commerce company, so you have a checkout service, you have, the product page, et cetera, et cetera. You have all these different things. It's just all one thing, and it's running on kind of one big virtual machine, right? Or one even before that, kind of a specific data center.
Right.
And the people who are developing and the operations team that was managing the actual infrastructure to host this and actually put it out in the hands of customers, those are fundamentally separate. There is a big wall right in between them. Then slowly, you kind of had this blend, and you kind of had this rise of cloud, thanks to folks like AWS and Google and others, where it became much easier to just spin up a cloud. You didn't have to, wait all this time. You didn't have to go through your infra team and infrastructure team and reach out and put in a ticket and wait, just like, you maybe would have to do to get access to a system as an IT team. And so then developer and operations slowly started to come closer and closer together. And we started getting something, instead of a monolith, we started getting something called microservices, which means your checkout service team, right? Developers are just broken into teams effectively. Your checkout service team can build totally independent of this other team over here that's managing the product catalog page. Right. That's totally separate from this team over here that's building the sign-in page and, responsible for that service. And we can build those totally independently and then connect them all back together. That's effectively what microservices is. It's super helpful when you think about developing things much faster, but where it gets complicated, as you can imagine, is how do I support the health of this service?
Yeah.
Because now, if it was one big thing, it's usually pretty clear when there's a problem. Oh, it's like that thing over there. It's not really working. When we're talking about now in a cloud first, right? We're in modern day now, we're talking about hundreds of microservices, maybe even thousands of microservices. It could be any number of things that's causing the issue. And that's really where DevOps has really come to the forefront of the field here, which is, what's a better way to think about the health of my systems and supporting these systems at any given moment, given that it could be one of 100, one of 1,000 different things that's going wrong. And a customer just says, I see latency, right? My Netflix app is not loading. What are you doing, Netflix? What's your problem? And, there's a whole team internally saying, I have no idea. As people have gone from this whole monolith architecture to cloud first, thinking about these microservices, how do we shift in what was originally kind of monitoring, right? How do I monitor the health of my kind of singular application? So observability is more the overall art of managing the health. So at any given moment, all these systems are giving out a ton of data points. And we call this telemetry. All right. And the telemetry is broken into 3 categories. You have a bunch of metrics, things like memory and response time. You have some logs, right? So every application has a log of exactly what is happening at any given moment. And then you have traces that's helping you tie it all together. So really the art and practice of observability is actually correlating across all 3 of these things. So I see a spike over here. Again, customer says something like, which is actually the worst, right? Is like a customer is complaining. Ideally, the best companies are really trying to shift from reactive to proactive. The whole reason they're using systems like Grafana and DevOps buyers all day and working with site reliability engineers, they're trying to make sure, how can we get alerted on the right thing at the right time? So we can identify something like, hey, I need this memory is full, so I just need to refresh it or shift this or that before a customer actually starts seeing some sort of reliance issue, which is really the job of the CIO today, right? Like their number one thing is to really think about, how can I reduce my revenue and my brand reputation. Because again, think about your Netflix, right? If your Netflix doesn't load, you want to watch TV, you're going to open Hulu, or you're going to open Disney Plus, right? You're going to wait maybe 30 seconds, a minute, and then you're gone. You're done. Similarly, if I'm a bank, that's huge dollars, right? If my app isn't loading, people can't transact. If I'm a retailer, Walmart, right? If I go down, that's real dollars that I can't generate for my business. And so, observability is trying to measure all things all the time to be proactive, not reactive. And if some of those shifts that took place and really this is the rise of DevOps, typically there was like one central IT team in a company. And that IT team was divided into developers and operators. The operators were the people who were purchasing and running the equipment. The developers were the ones who were installing those apps on that equipment. And everything was on a single server, right? So the IT people would set specific thresholds of capacity. So this is how long we think it should take. This is how much capacity we think it will need. And then they bring that out to the rest of the company. And the rest of the company had to sit within kind of those limitations that the IT team has set. As companies are starting to go to some of these kind of more modern infrastructures, now developers can spin up their own server with the swipe of a credit card. Right? It's literally now seconds. You're no longer relying on a central IT team and their limitations and capacity. So now you have kind of unlimited elasticity there, right? You can scale up, scale down with literally a couple of clicks. So now the IT team is starting to run kind of very close to that kind of ceiling in terms of costs, right? How do we get just enough that we need at any given moment? Because if we ever need more, we can very quickly increase it. We don't want to be proactively paying for all this extra space. And then we want to alert, right? If we get close to the kind of red line, we're getting close to that capacity, we want to alert. But now this is across many different teams. And so now different teams, that architecture is getting a little bit more complicated. So all these different teams are starting to put in kind of new tools to help better understand the health of their systems, to make sure how each individual one, again, is getting close to that capacity. And so within that, right now, these individual teams are bringing on experts within their specific teams who can get closer to the specific platform and thinking about the health of running this platform. And that those people, those experts that they brought onto their team, that is the DevOps and the site reliability engineers kind of specifically. That's where they kind of got rise. Yeah, it's a culture, a DevOps culture, a developer culture that I would say is the most challenging, is because depending on, not all companies modernize at the same pace or at the same time. And so we just talked about the spectrum of, you have one central IT team kind of dictating the rest of the organization versus you have an individual kind of DevOps individual within teams. I would say some of the best companies in the world also have a build it, fix it model, which is to say we're not going to have a person on your team that's responsible for doing all this, but you as the developer, if you are building code or building software, you should then be somewhat knowledgeable about how to fix anything that happens within production, right? You're now responsible, you've built it, so now you're on call to fix if there's any issues for your specific service. And so that, can be one, challenging. It's a whole new skill set for that individual, but at the same time, it is new complexity of like, now you have to make sure you have the right person on call, because if they didn't build it, they probably don't know much about it. They have to get, the person that actually ended up building it. So that becomes super challenging at scale for sure. But then anywhere on that spectrum is also really difficult of, how do I get to kind of the next piece? The big challenge DevOps is facing is, depending on where you are, it's still kind of a throw it over the fence model. So the developer is just building, they throw it over the fence and say, hey, DevOps person, you were hired to make sure this is, healthily running at any given moment. Good luck with that.
Right.
And the DevOps person is saying, no, like, this is you and me together. We need to work on this. You're the one that built this. I don't know. I know about maintaining systems in general. I don't know about this specific system. I need us to work together on this. And they're saying, no, that's not my job. I'm going to go build something else, right? It's a real, tough time. And that's why folks, like I mentioned, have been going towards this kind of build it, fix it model to kind of adjust the empathy. And as marketers, especially, I think we're guilty of this, which is all the time, we're closer to the front lines with customers, and we see these issues and we hear these issues, and everyone's like, oh, why can't the developers build it? Why can't the developer just fix it? Why do you make products that have problems, right? Like, why would you do that? And it's so easy to just say that, but then you start to dig in and understand the nuance and the complexity. It happens within the engineering team as well. But, finger pointing, that's not my responsibility, those games. Yeah, I would say a practice that not a lot of organizations have well mastered is how to best quantify what does a reliable system actually mean? What are we measuring and using as a core definition for measuring this? And so a lot of people may know the concept of an SLA, a service level agreement, right? It's usually something that they write in a contract. You may see this, especially on websites. It's like, oh, we guarantee 99.5 uptime, or 99.9, or 2 nines, or 3 nines, whatever. It's something that a company contractually agrees to another company that they typically work with or sell to, that, hey, we will guarantee you this much of system availability, and if not, there's some consequence to that. There's actually, interestingly, 2 other types of reliability metrics internally that organizations have. So there's also an SLO, which is a service level objective. So contrary to the SLA, which is kind of customer facing, the service level objective is similar concept, but this is internal. So it's typically a goal that's higher than your SLA. So let's say that our SLA in our customer contracts is 99.5% that we're promising everyone. Maybe our internal service level objective is 99.9 consistently, right? So we want to shoot to be even better than what we're promising customers. And then we want to, measure a couple of things to make sure, understand how far are we from that, or what's stopping us from getting there effectively. And measuring kind of what's stopping us from getting there is kind of, these metrics are SLIs, or service level indicators. So this is something like a product characteristic, typically something like a percentage. So what was kind of the system availability of X and YZ system, and then you bring all those up together and you have this service level objective, internal, again, kind of a KPI, if you will, versus your service level agreement for customers. Lots of acronyms, but it's really thinking about, how do I do this at scale, right? Monitor all these systems consistently so that, when we promise something for customers, it's not an arbitrary number, or it's not something that they just said they'd need. And so we just said, sure, fine, whatever, and we'll figure it out. But it's much more thoughtful in that approach, a systematic approach to this, if you will. Yeah, I think it all falls into kind of three main categories of things to think about. There's kind of, if you think about a big spectrum of DevOps, there's some shifts that have been occurring. So there's and again, when we talk about a shift, we're thinking about that wall between ops and developers, or the IT team, the central kind of IT team, and the actual developers who are building things. So if we shift to the left of them, which means get closer to what they're thinking about, it's all about preventing and testing things before they even get into the hands of into the hands of customers. So you have things like load testing and browser testing of fields that's kind of somewhat new, which is called chaos engineering, which is effectively the whole practice is all about how can I replicate what I'll potentially see once my customers are actually using this. So for example, if I am Walmart, again, I am thinking about how can I test the load of what I will see on Black Friday, where earned traffic to our website might be 10x, ideally 100x. How do I make sure that I understand how my applications perform at that level without actually getting there, right? Because ideally, you don't want to be testing that on the day of. You want to do a dry run. So how can you think about preventing these issues? If not, how can you think about quickly finding these issues proactively? And this is where we talked about kind of the core tenets of you have some metrics, you have some logs, you have some traces, and there's a way that all of these will work together to help you define exactly what system at what given moment is causing the issue at one given time. And then if not, kind of the last piece is if you can't be proactive and you aren't able to prevent, how do you act quickly whenever you do find an issue? And so this is kind of some of the core products that I initially started out at Grafana, which is this is the shift right to purely operations teams, which is my incident response and my incident management. So like we were mentioning, who has the expertise in the organization? How can we reduce the time it takes to get that expert on the line to help us understand and put some context around, is this a huge issue, a medium issue, a small issue? Is this affecting customers, not affecting customers, right? We want to treat all of these differently. And then once we've resolved this issue, how do we make sure all of the kind of critical pieces of information, what the issue actually was, who found it, what worked, more importantly, what didn't work, how do we make sure we have all this well documented and all of the stakeholders are well informed? So now we can talk about, well, what are we going to do different now today that we've learned this to go back to preventing this issue in the future? And that cycle will just kind of continue of preventing, finding, and if not, acting quickly.